This is exercise 6A on the language of polynomials on page 210. So Riley, what did you say what quadratic was? Awesome, a polynomial. So quadratics in the equations, and later on we'll talk about cubic functions. Can anyone guess what cubic functions have its power to? Three, easy. What about quartics? Easy. So learn about different types of polynomials. A polynomial is just a function where we've got different terms with a variable in it. Okay. So in this case, and now you guys are all familiar with f of x. In this case, I'm just writing p of x. Same idea. I'm going to write p of x equals to a and x to the power of n plus a blah 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 blah. That's the complex way of just saying any number where I've got a variable. So for example, x power of, let's say 7 plus x power of 3 minus x power of 2, something like that. That's a polynomial. Anything where I've got a variable and then I've got the powers there to indicate the degree. Does anyone remember what the degree is? Degree of a term.
The number is power.
Awesome, the number is power to, or the exponential, right? So for example, x to the power 7 has a 7th degree. Now we're focusing on the leading term, the leading term being the term with the highest degree. So for example, in this situation over here, what's the leading term? Can you guys see that off the back? Yeah. What's the leading term in this equation over here, in this expression? Zach? 2x to the power 5, not x cubed. So most people think x cubed because it's the front. No, we think about the one with the highest degree, 2x to the power 5, and therefore has a degree of 5. Okay? Pretty straightforward. Now a monic polynomial is a polynomial where the leading term coefficient, so the one with the highest degree, has a coefficient of 1. So this is just terminology. You don't have, I won't strictly ask you in most situations, for example in a SAC or test, I'm not going to ask you, is this a monic polynomial? But it's a good idea moving forward to understand that terminology because we're going to be using it a little bit. So a monic polynomial just means coefficient of 1 in front of a leading term. Easy. Arithmetic of polynomials. We've already touched on this a little bit. So for example, if I have f of x equals to 3x squared plus 1, hopefully you guys remember from the start of this year and during Head Start, we said, well, f of 1, what do we do there? Yeah, we substitute x is 1, so we'd say 3 times 1 squared plus 1, which gives me 10. Not 10, sorry, 4. Okay? So we just substitute that there. We already know that. Now we're looking at the arithmetic of polynomials. Instead of substituting a value, why don't we just add the values, add the expressions themselves? So let's say in this situation, hopefully you guys can read that. Sorry, could you turn off this row of lights for me? Thank you very much. So let's say q of x is x to the power 3 plus 3x squared plus 2, and px is 2x squared plus 4. Now, we've got a cubic function because it's the power of 3. But we've also got a quadratic. So in this one, let's go ahead and use green to show this one. P of x plus q of x, how do we add them together? Well, it's exactly what you think you'd do. You just add them together. So let's write P of x, 2x squared plus 4. Let's go ahead and write q of x. So add q of x, which is x cubed plus 3x squared plus 2. Have I lost anyone? Okay. All you can do now is collect your like terms. So is there any way we can add x cubed? No. So I'm just going to write x cubed. Do I have any x squareds? Yep, so add them together. 2x squared plus 3x squared gives me?
5x squared.
Good. And then I add the constants, or the whole numbers. So 4 plus 2 gives me 6. Bam, that's it. So we add quadratics or add polynomials the same way we do with linear equations. Now, same idea. What if I was to do it with a negative? So I'm saying taking away. Same idea, except we're going to draw a better arrow. There we go. Same idea. P of x is 2x squared plus 4. And remember, we're taking away the whole polynomial. So I'm going to go ahead and write minus, and then q of x, which is x cubed plus 3x squared plus 2, which would simplify to 2x squared plus 4. If I expand that, negative x cubed minus 3x squared minus 2. Does that kind of make sense? Easy. And then over here, simplifying that, I get negative x cubed minus x squared plus 2. So it's pretty intuitive. It's just what you guys already know, but we're applying in a polynomial situation. What does this mean over here? Multiplying, easy. So I'm not going to go through the whole multiplication. It's going to take some time, but it's exactly right. It is multiplication. So I'm going to write P of x oops. So p of x, which is 2x squared plus 4 times x cubed plus 3x squared plus 2. What's the problem with me doing this? There's no brackets. I need the brackets because I'm multiplying the whole polynomial, not just the 4 and the x cubed. So I'm going to write bracket, 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 bracket. Now you guys already know FOIL, expanding brackets when I've got 2 terms in each bracket. What happens if I've got 2 in one and 3 in the other? It's the same principle, but we don't use FOIL. Same principle. Because the whole point of FOIL, if you remember, is that you want each term to multiply with another term in the other bracket. That's what FOIL is. So I'm going to do the same thing. I'm going to go 2x squared times x cubed, and then 2x squared times 3x squared, and then 2x squared times 2. And then do the same thing, but go over here and say positive 4 times by x squared, positive 4 times by 3x squared, positive 4 times by 2. Once you do that, everything else is exactly the same. So I'm not going to go through that. It's a little bit tedious, but that's exactly what we do. Do I have any questions about that principle there? No? Okay. Up next, equating coefficients. Once again, it's more simple than you think it is. The only thing to remember is that when we're equating a polynomial with another polynomial, it means that the coefficients are the same. So in this situation, I've got p of x equals to 4x cubed plus 5x squared minus x plus 3. So obviously there's a 1 here because there's no number there, so it's minus 1x. Now in this situation, I've got some unknown values. So instead of a certain number, I've got b3. Instead of a certain number, I've got b2, etc., etc. So what does b3 have to be in this situation to make it the same as the other polynomial? Well, it's just going to be the number in the other polynomial. So reflecting it, well, that has to be that, right? So b3 has to be 4. What does b2 have to be? 5. Moving on, b1? Minus 1. And so forth. So you get the idea that when we equate our polynomials, it can only be the same if the coefficients are the same. Okay? So that's just a general principle to apply to apply. It's not really something that is, how do I say, a specific terminology. So as long as you know that when you expand it, etc., we've got variables, you know that you can equate coefficients and we'll find the same polynomial. Last concepts. This one over here, can anyone tell me what the first formula tells me? What is the first formula? Expanding what? Yeah, expanding perfect squares or expanding brackets when we have 2 terms. Now that's the formula we know. You can do this by hand, but that is FOIL. Okay? In terms of the same result. If we have a plus b all cubed, you can expand it. Now what I'm going to do is I'm going to write it out. So I'm going to say a plus b times a plus b times a plus b. Do we agree it's the same thing? Yeah, awesome. Now we know that a plus b times a plus b is that formula right there. So would you agree if I write this? A plus b times a squared plus 2ab plus b squared. Would you agree it's the same thing? Easy. So from this, we can actually derive a formula. So I'm going to just write, I'm not going to go ahead and expand it. I'm just going to go ahead and write it out. If you keep doing this, you get a cubed plus 3a squared, b plus 3b, that's not right, ab squared plus b cubed. So we get a cubed plus 3a squared b plus 3ab squared plus b cubed. That's the formula you can use. Now, when I was in high school, I don't know if I've told you guys, I still have a terrible memory. I never memorize these formulas. If you don't like memorizing formulas, you do not have to. What I did is I just expanded everything by hand. And you're more than welcome to do that as well in your SAC. So, you can use this formula or you can expand it by hand. The same thing applies if you have a to the, let's just write it down, bracket a plus b all to the power of 4. There is another formula. Now this one's used a bit less because obviously it gets a little bit more complex. But there's a formula for that and there's more formulas so on. Later on, we'll learn about this concept called Pascal's triangle. I'm unsure if you guys heard of that. You guys never heard of that, right? It's a very niche mathematical concept. But later on we'll talk about that and talk about how that's relevant to these polynomial expansions there. But the three main ideas I want you to focus on for this lesson, or this exercise, so to say, is polynomial terminology, focusing on arithmetic of polynomials, equating coefficients, and just that expanding polynomial formulas. Any questions?